Many people worry about rising inequality, yet most countries release data for measuring inequality only at the provincial or state level, so local inequality remains unexplored. Researchers have therefore used big data on satellite-detected nighttime lights to measure inequality in local economic activity. These measurements help track progress towards United Nations Sustainable Development Goal number 10 on reducing inequalities. The most popular data are from the Defense Meteorological Satellite Program, DMSP, yet this was not developed to measure lights nor to monitor activity on Earth. DMSP data reflect limitations of satellite and sensor technology from last century, attributing light to unlit areas and blurring differences between brightly lit places like city centers and dimmer places like suburbs. These distortions create spatially mean reverting errors, so DMSP data are poorly suited for measuring inequality. In contrast, newer research-oriented satellite data, such as VIIR's Night Lights, VNL, and NASA's Black Marble, BM, are designed for Earth observations without these errors. Yet these newer data are largely ignored by studies measuring inequality. In a recent Regional Science Policy and Practice study, researchers examined distortions in inequality estimates due to spatially mean reverting errors in DMSP data. The research relied on 2 decades of annual data from over 5,000 counties in China and the United States, the 2 largest countries with benchmark data on economic activity down to the county level. They use a visual example from the U.S. state of Wisconsin, conveniently bordered on 2 sides by water and sparse populations to minimize outside interference. Population and economic activity concentrate in 22 counties in the southeast of this state, near the largest city, Milwaukee, and the capital city, Madison. These counties generate 74% of state GDP, are home to 69% of the population, and to 2/3 of luminosity using the accurate VNL nighttime lights data. Yet the widely used DMSP data paint a very different picture. Unlit areas seem illuminated in blurry DMSP images. Just 47% of DMSP light is from the southeast corner. The sparsely populated parts of the state with less economic activity seem to have a majority of lights. Notably, small towns like Oshkosh seem as brightly lit as Milwaukee. A common measure of inequality, the Gini coefficient, is only 1/2 as high using DMSP data compared to using VNL data. In other words, the popular data greatly understates spatial inequality. To show the generalized nature of these biases, the researchers also estimated spatial inequality for all county-level spatial units in China and the United States. For the United States, DMSP data underestimated some inequality measures by 60% compared to what benchmark GDP data show. Yet there was no understatement of inequality with the newer VNL data. Results for China showed similar patterns, and the trend in inequality is distorted if using DMSP data. For example, from 2000 to 2013, the THEL Inequality Index fell 28% using DMSP data, but neither GDP nor VNL data showed a big fall. The exaggerated fall in regional inequality with DMSP data is from when interventions to aid economically lagging regions were prominent. Hence, studies using DMSP data may give a misleading guide to success of these efforts. Overall, these findings show that spatially mean reverting measurement errors in DMSP data significantly lower estimates of spatial inequality and may potentially mislead policy. However, utilizing newer and better nighttime lights data can help accurately measure spatial inequality and would be a sounder basis to use in future for assessing progress in reducing inequalities.